What this is a story about 7 years ago, when I was working for an ad tech company, and I felt a pretty intense amount of pressure to deliver that forced me to do things a little bit differently and pick up new tech, new languages, all that kind of stuff. And in that, I kind of changed how I approach picking up new things. And I kind of wanted to share that story because it's pretty common. We have to pick up new code bases, new stuff all the time. So what options do we have? Because my normal way is what I found most developers do isn't really the only choice. Um, so one of the thoughts that I have behind all this, kind of a theme, a question in the back of the mind, is how much of our code and how much of our tech is fundamentally based on hope? How much faith do we have to put in all the things working the way we think it does for our code to work right? Do we really know all those configurations? Do we really know our environment so well? What happens when that stuff goes wrong? Right? We've all felt that. It's not fun. And yet we live with so much of that. We live with so much of the faith. So that's kind of the backdrop of why I had to change what I did during all this. So sort of a theme behind what's going on. So I need to set up the stage a little bit here in terms of what was the pressure that made me do something different. What had happened is I was working at this ad tech company, again, 7 years ago, and we had revenue, but we weren't profitable. And so we were on our last few months before we were going to run out of business. We had just a little bit of time left. So we had one last shot at what we were going to build. So the CEO wanted us to build his super idea, which he called Skynet, but essentially it's a real-time bidder. And what that is, just to explain, is when you load a website that's going to show you an ad, what it does is a little bit of JavaScript collects all that wonderful personal information that you totally consented to give and sends it along, as well as the information about the site you're on, to what is called an ad exchange. The ad exchange, upon receiving that request, hosts an auction where it takes the second highest bid and shows their ad in a less than a tenth of a second. And that's how most of your ads actually come up. That's what happens. An auction takes place. And a real-time bidder is the thing that sits on the other side, receiving all those requests and bidding to show an ad. So we were going to build one of those. The crazy kind of thing about this is, if you can imagine, performance is kind of a serious game for ads. You have to get the ad in front of people quickly, because if you degrade overall performance, things get bad. They won't click your ad or whatever. And in these exchanges, they had particularly difficult requirements to hit. So the easy one we started with was to hit a sustained 9,000 requests per second with a round trip latency of 120 milliseconds. So the moment they start the auction till the moment they get a response, 120 milliseconds. There was also some rules about what kind of error responses we could give or stuff like that, but they were so small it kind of didn't matter. Like, we just had to get it right. We couldn't afford really big, fancy Amazon EC2 instances. We had to kind of basically do this on the equivalent of a laptop, because that's what we could afford. And at this point, there's a connection between our lack of money and the whole concept and scale, which is what we were going to build was going to potentially spend money 9,000 times a second. So I did a little bit of math and calculated we would bankrupt the company in 15 minutes with just the right kind of bugs and how we spent money. And that 15 minutes included all the cash we had left, plus tapping into the lines of credit we had left over with our investors. 15 minutes. So surprisingly, when I brought this to everyone's attention, like, we got to get this right, everyone was like, nah, don't worry about it. It's not a big deal. We have alerts. And I thought that was hilarious response, because it would assume we knew what to put an alert on, like what's the magic number we would put where we're like, this is dangerous. And that the timing of the alert getting sent, getting received, someone taking action, logging into a computer, logging into Amazon, all that stuff to shut it down would happen within 15 minutes. I was like, yeah, I don't really like that margin so much. So I can't really afford a bug in how this thing spends money, because I could destroy the company in 15 minutes. What else? Oh, the architects at the time thought it would be a great idea to change the tech stack. Previously, the company worked primarily in Java and JBoss. And so perfect time to switch to Scala and a framework that had not been identified yet. Eventually it would be Finagle, which is Twitter's service framework. And I think it's actually pretty nice, but that's a lot to take in all at once. So I asked, do we have anyone that does Scala? The answer was no. Not even like a hello world on the side kind of thing. Could we get books? No, we don't have money. Certainly can't get an expert to come in and help us either. So it was, we hired smart people. You'll figure it out. And like all good projects, a deadline was set well before any of this was understood. And of course, there was a real deadline where we were going to have to shut the doors because the business was out, money. And then there was a deadline for the project, which was well in advance of that, because they needed to figure out what was going to happen with this. So there's some pressure to figure this all out. So normally, what I would do, given a circumstance where I have to figure out how am I going to pick up all this stuff, is to go look at stuff online. Video tutorials weren't really a thing 7 years ago so much, but tutorial sites, blog articles, official documentation, all that kind of stuff. I would comb through it and begin to build on the stuff I was learning and Google what I was seeing and try to figure it out. That's how I would normally do things. And that's what most all my peers do. And it seems to be okay. And it certainly would get me to the point where I'd be writing code. Where what I began to feel like, though, was that was not really a good way to do it this time. Because every time I would do that, take this approach, I would wind up with these really, really long debugging sessions. Because inevitably, the tutorial I would start to look at had different versions of software that no longer work, or slightly different configurations that I didn't have, or they were just written so that they couldn't be followed correctly. It could be out of date. They could have just been written poorly. And the problem is when a tutorial is like 30 steps long and it doesn't work, you don't know which step broke. So all 30 steps are a problem. Everything from the versions of the software, the environment, your configurations, the tooling, the code, all could be messed up and you don't know why. And you spend forever trying to figure out and you don't know what to look at because you started looking at this because you didn't know. So how on earth am I going to know now? So that was not really what I wanted to experience. Because again, I'm thinking of, I can't afford these kind of problems right now. I have to have certainty in what I'm doing. So, and in particular, I'm going to poke fun at Scala. If any of you are Scala developers, I'm not making fun of you, but why not poke fun at tech? We've got to be able to laugh at it, right? So looking at Scala documentation it gave me fits. So here's an example from Finagle's documentation on the filtering class. So as you can see, it's a class that has 4 different types, and it extends a trait, which is a function that returns a future. Super easy. And they even provided this really helpful diagram about how to understand all those inputs and outputs and what's going to happen with them. So really, we all got this, right? Now, I do need you to kind of remember that function definition because I'm going to bring it right back here in a second. Because, you're reading this, you're like, got it, no problem. Then you might say, what are all those pluses and minuses and stuff? Well, now we have to introduce the concept of covariance and contravariance and invariance in terms of Scala, which I am convinced to this day no one can actually explain. It's not exactly about subclassing and any of that, even though that's what this looks like it is. It's more subtle than that. And there was also a footnote that if you didn't catch it, it would have explained that the future that was in that function definition is actually Twitter's own future implementation that deviates from the standard. So if you had a problem with futures and tried to Google what's going on with your future, you'd have to remember, it's Twitter's implementation because they refuse to follow the standard. So documentation for the win. So with all this going on, what did I decide to do? Because I wasn't making much progress on the documentation side of Scala. It was just pretty opaque. I basically, what I did know, right? What I did know is when I got into the code, what I really wanted to do was do test-driven development for the budgeting side. I wanted to use TDD to test the poot out of how we were going to spend money. Now, some people will be like, TDD isn't about testing. I'm going to say TDD can absolutely be about testing if that's what you want to use it for, because you are testing. And that's what I really wanted to do. Yes. Simple is never simple. So I wanted to get there, but that would be when I was actually writing the code, and I'm still stuck at I don't know anything yet. I can't. The gap between where I am and where I want to get to, where I'm testing the budgeting stuff, is huge. So how am I going to get there? This is also the time I was really actually learning about TDD for the first time, and one of my coworkers who was way further down the path than I was sent me screencasts by Gary Bernhardt, who does Destroy All Software. Now I can kind of describe what an impression it had on me, but at the time I was just sort of like, and he in those screencasts would just build software and kind of describe some programming concepts as he did it. And he always did it using TDD, but something in particular stood out to me was when he would run the tests, the output would just go by in a flash. It was like he didn't read it, which made no sense to me, because every time I had written tests before, not doing TDD, you spend forever reading those stack traces and figuring out what's going on. But it would just flash by and he would keep going. So he was doing this stuff really, really quickly. And what I wouldn't have been able to articulate then, that it could articulate now, is fundamentally what Gary was doing was confirming a prediction. When he wrote his test, he was predicting what would happen. And when he ran the test, he was just confirming a prediction. The information in the output was only there to confirm something. It wasn't information to him. He didn't need anything from it. It was the test passed because that's what he predicted, or it failed for this specific reason. Those were his predictions. So he just needed at a glance to catch it. And this kind of rolled around in my head like, so this dude is making predictions, running these tests, confirming that they're correct or not, which feels awfully a lot like a watered down scientific method kind of thing, which means to me, I could stand to learn something if I did this. So without much else to go on, knowing I didn't want to do it my old way, I decided to give it a shot and try to do something kind of like TDD, but instead of focusing on tests or software design, I was going to focus on learning stuff. And so kind of conceptually how this looked, you can tell I drew this, was this, TDD is commonly described as a red-green refactor loop or whatever. Well, in action, I would do the same steps, but my intent was completely different. What I really wanted to do was form a hypothesis or a prediction about what was going to happen based on what I understood or assumed, execute an experiment, which in this case would be running my test, and then essentially respond to the results. So it could be taking an action in terms of cleaning something up like a refactor, or it could be making an adjustment and seeing if the results are the same to test my knowledge. And this is what I began to do. Now, the trick is, this is a slightly different way of looking at it than a normal TDD cycle. But the key aspect to doing it is, what are you making a prediction about? Like if I was making a prediction about a big thing, like can I ship it to production? Well, there's only about 1 million things that could go wrong with that. So when I see a result, how certain am I about my prediction? Not actually all that certain. I wouldn't be willing to bet money on it. So a big part of the prediction is getting things down to the point where it's got to be like a yes, no, a true, false, a 1 or a 0 level of mistake that I can have. Because if it's that simple, I might actually learn something. If it's more complex, I may not actually learn anything. So I need to break all my problems down to the point that they're that dumb. And I actually do tell people this to this day. It's like breaking it down to this small should feel like when you're done, it's a chore. Like it's mindless. It's not even that exciting. It's just almost repetition. Folding laundry, right? There's nothing magic about it. You just do the motions. It should feel that small. So an example of what I would have done is, let's say I want to get to the point where I'm running my Scala project in IntelliJ. That's way too big. And even though every tutorial site, that's like a halfway point before you get to writing some code, I'm saying that the halfway point of even running anything in IntelliJ is too big. So how I might approach this problem in this idea is I would run SBT. SBT is Scala build tool. It's the compiler that they would use. And I would run it. My prediction is it shouldn't run because I don't have it installed. Now, when I do this with teams today, they are like, they lose their minds at this, like, why would you waste your time? You know you don't have it installed. The problem is I don't actually believe that assumption to be true more often than not, because when I'm writing code on a computer, it is a graveyard of failed starts for all kinds of stuff. A project I did 2 years ago has all the junk I still have installed all over the place that I don't remember what's there and what's not. I don't remember what dependencies were installed for everything. The likelihood of me accidentally having something on my computer is not zero. To give a more specific example, if I were doing something in Ruby or Python and building on the Mac, those things are installed by default. And I wouldn't have known that unless I ran it this way. I could have looked and found it, but if I didn't know to even look, how would I have known? Which means if I tried to do an install because I assumed, did I mess up a global install? Did I do something wrong? I needed to test the assumption. Because when I do install it and it does work, I am sure the command is working with the thing I intended for it to be there, and not some ghost version from, years of Scala past or something like that. So I'd run it, see what happens. Install it if it's not there, confirm the version's the one I expect. I'd try to run SBT with a file because I want to see it give me the error. I want to see it respond to me. I might run it again with a Scala file that's just a bunch of commented out code because I don't want to test the Scala code yet. I want to test my expectations of how SBT will respond. And so then I might do it with two files. I might do it with two files in different directories to simulate a project structure. Then I might load a file in an editor to make sure that side works. And then I might run that file through SBT through my editor, and then two, and so on. And each of these steps, I'm just trying to introduce one new variable at play. By the time I'm actually writing code, I have a lot more confidence that all this stuff behind the scenes works the way I think it does. And that's kind of my approach. And all these steps to most people seem insane, but they help me because I know kind of what the options are for SBT. I know what it does when it doesn't like something. I know how those things connect to my editor and all those things. I have a better picture of all that. Now, some people might say you're testing your tools and that's not what you're supposed to do. And I would say, well, kind of. I'm not testing that the tools are correct. I'm testing my knowledge of the tools. So they look the same in terms of things like I'm testing SBT runs. That's the test. But the reality is I'm testing my expectation against it. I want to guess that it should throw me an error. And I want to guess what that type of error should be. And when I run it and see that error, good. My knowledges or assumptions were correct. And if it isn't that, I'm about to learn something. Every time I get my expectation wrong, I have to learn something. So it's forcing that on me. But all good stories have a problem. So at some point I was writing code and everything was going magical and I felt good and I was doing TDD and it was sunshine and rainbows and unicorns. And then I got clever. I got really clever and thought I could do some good design work using Scala that I barely understood. Now, I don't remember exactly what I did. What I do know is in Scala, there's a concept of traits. And traits are a kind of a magical little thing that could be, they can be like an interface or an abstract class or even a concrete implementation that augments an existing class, which is a powerful concept. But when you couple that concept with a very strongly typed system like Scala with concepts like covariance and contravariance, you can very easily make a mistake. And since my background was primarily Java at that point, and I'll say something that's probably going to be a little controversial, but in Java, even if we know composition is better than inheritance, pretty much every tech stack we use forces inheritance first. We always have to start with some level of inheritance before we can begin to compose. And so even if we know that's not like what we would like to do, we are kind of, at least for me, I was deeply trained to begin with a certain amount of inheritance before I could begin to compose. And I did something like this with traits and it blew up in my face. So here's an example of a stack trace from SBT. This isn't the stack trace for what I was bumping into. It's just one that's kind of, shows the level of helpfulness that all stack traces give. And because I was being clever, I violated my rule about taking a tiny, tiny, super small folding laundry type step, and I got stuck for a couple days. And I had to break the problem back down and unwind a bunch of stuff, and eventually I cracked it. And when I did, I finally learned a bunch of key concepts about Scala and its typing system and all that stuff. And then, the rest of the project, it was far more about me expressing myself in Scala than learning it. And that meant how I was using this TDD loop changed from a learning thing to a more of a design and testing framework, or whatever we would like to describe it commonly. But I hit the same problem I always do. I took a big step and messed up. But the whole time all this is happening, all those tiny steps, even here, even with the stack trace, what was becoming really, really clear to me was when I would make these predictions, I was asking a question to my tools. And when I would execute my experiment, my tools would say something back to me. And for a lot of work that I do, this is a one-way conversation. We don't really understand what our tools say to us, so we go Google it and we look it up on Stack Overflow. We don't know what it's trying to tell us. If you're a Star Trek fan from The Next Generation, there's that Battle of Tanagra episode, and it's like that. It's using words we should understand, but they're in a way we cannot make sense of them. But when I took this learning approach, I was asking a very specific question, a yes/no question, and I would get a response. And pretty quickly, I was beginning to map my questions to how I would get an answer back. So when I would begin to see these common answers, I knew through developing a sense of language and dialogue with my own tool set what the issues were. Not in a I read about it somewhere kind of way, but more in a intuitive or visceral way. Like if you're learning a language, eventually it becomes, you don't have to think of the word, you can just kind of conjure it up. It began to feel like this, that I had more of a dialogue with my tool chain than it just said garbage at me. What am I going to go do? So this is kind of what I began to do. And by the time I passed this threshold, I was in the sweet spot of knocking it all out. So what I feel like I should do is kind of tell you what happened at the end of the story. So we shipped the project 3 days after our deadline, which is pretty good, not too bad. It had no bugs and no defects and no outages, also pretty good. How long did it take for me to get to that stage in the Scala in this? So the whole project was 3 months, and I feel like this particular mistake of design. I'm trying to remember back, right? I want to say it was probably like month and a half to 2 month mark is when I hit this particular construct. I had written plenty of code by then, but I hadn't been clever about it. And I was kind of avoiding certain concepts in Scala because I couldn't make sense of them. And then I got clever and this happened. And when I got past it, I felt a lot more confident in what I could do in Scala and began to rework things more confidently. But I feel like it was month and a half, 2 month mark where I really hit this wall with this pop problem. A lot of the code was there and it was working, but wouldn't say it was good Scala code. It was working code. So we finished it in 3 months. Well, 3 days after the 3 month mark. No bugs, no defects, no outages. We did not bankrupt the company in 15 minutes. And we managed to keep up with the scale. There was no problems with the scaling. We weren't banned from the exchanges because of failure to meet their SLAs. Now, all that sounds good, but that bio that I wrote, there's a reason that bio is there. So this was the CEO's pet project to save the company. Turns out the product manager who was there quit right after we shipped it because he was tired of being a product manager who essentially had no voice in a product. And he was tired of working on stuff that didn't matter. So he quit. So we transferred the project to a new group. So I had to transfer this whole thing that I wrote to another team who did not know anything. So I did everything I could to help them, whatever. One of the things I did was code reviews. I would help them with code reviews. And I saw one day there was a change in the like 5 lines of code or whatever I had that made sure we did not spend too much money. And along with that same pull request, there was a test that was deleted that tested that we didn't spend too much money. And I lost it. And I went over, I was like, whoa, this is the exact thing we can't have happen. He's like, nah, it's fine. Don't worry about it. It's not a bug. And I was like, can you provide any test to do that? Like, well, no, I deleted the test. And I was like, did you delete the test because you made a change and it stopped working? And they're like, yeah, the test is bad. And I was like, everything you're saying right now is wrong. But it's your problem. So if you don't want to fix it, that's fine. I do have to let people know that this is a risk, though. They're like, but it's not. I'm like, well, I got to do my job here. So I went and told the product people, like, you might wind up overspending. And they're like, well, how much? And I was like, I don't know. As if there was a way to test that. And so he was like, well, okay, how hard would it be to fix? And I was like, right now it's 5 minutes. Like, just undo that change. I'm like, oh, then forget about it. It's easy. We won't do it. So they shipped it. And sure enough, they began spending more money. Now, it took a little while for the CEO to catch up to that because it took a while for the bills to come home. And then sure enough, the bills were more than what he had budgeted for. It wasn't going to kill the company. It wasn't overspending at full tilt. So that prompted a whole lot of concern about everything. And the data scientists basically confirmed that this would never work. All it can ever do is lose money. The product people disagreed and said the problem was scales. They turned it from 9,000 requests per second losing money to 120,000 requests per second to lose money. And the company ran out of money and was sold, and the project was shut down. Woo. So that's how that story ultimately ended. But what happened for me is, well, up until this time, right, I had taken a lot of pride in feeling like within a few days I would be able to write code in a project. And I don't feel that anymore. I don't feel any pride about that. I feel almost embarrassed because what I had been focusing on that whole time was getting to the point I was going to be able to write code, as if writing code was a substitution for shipping working software or doing good work. My desire to get to the point where to writing code was fundamentally like selfish. Like, I enjoyed that part. So if I got to that part, it was good. And I didn't feel like I could afford, in this particular case, that. I kind of fundamentally, I guess, knew deep down that it wasn't always as good as I hoped it was, and I wanted to do something different. So I don't really boast about that anymore, and I don't care for it because after this experience, I became keenly aware of just how much I didn't really know about the code, the tools, the environment, the configurations, everything that exists around the code to make it work. Every time I would go to a new client or a new company and I'd have to onboard to something, and everyone's like, oh, here are a bunch of instructions that are outdated. No one really knows how anything works. Please don't touch anything. Don't poke the bear. Just hope it works and never touch it again, please. Right? Like, no one knows what's happening. It's hope. And we might be building multi-million-dollar projects, and the core of it is we hope it works because we have no idea what to do if it doesn't. And I don't really care for that anymore. That doesn't mean I'm like hardcore about it like I was in the story, but I do keep this same intent intact. I start with really small, tedious tests that I walk through things that I've been doing repeatedly for years, and I do them because I don't want the surprise anymore. I want certainty. And so, the teams I work with don't enjoy that experience, but the thing that I would say for every team I've done this with for the years since, there's a common problem that pops up all the time that I think pays for itself, which is when teams start new projects, which isn't always a common experience. It seems like everyone bumps into a problem where, they get all their tools and editors going and they set up a project structure and they start trying, and then something falls apart immediately. And usually it's because some configuration or something is set up where it can't find the files anymore. something was wrong with that. And they don't know where to look because they tried to do everything in a big blob of stuff at once. But when I take this approach, I specifically make it a test to go from one file to two files. So when that breaks, the only thing I think that can go wrong is looking at multiple files. So I know exactly where I should be looking when that breaks. And that means when I get past that step, I can accomplish setting up a project. But when all these teams I've worked with in the past that skip those steps, they hit the wall of, well, we don't know why these things won't run. It says it can't find a file. It says this, it says that. Well, the big lump has failed them. And so, it feels like this race where I'm the tortoise and the hare, right? They're running straight towards code and I'm creeping along with my little things. And then they hit this wall of a marathon debugging session that could last days or weeks. And I just keep on cruising by. And I look like I'm sitting there folding laundry doing nothing, and they're sweating hard trying to get all the stuff to work, but I sleep well at night. So that's kind of what I've taken away from it over the years. And so if this idea is at all compelling to you, if you think you want a little less hope or faith or a little more certainty, what I would emphasize more than like TDD stuff, the real things that I would say are the most important is you have to make a prediction, because if you don't get the surprise, you may not learn, right? So you have to make a prediction. The other thing is the super tiny steps. Get it to the point that you're folding laundry. Like, it's a chore. The nice thing is that because it's super small, you're not doing it for very long, and you get the reward of aha really quickly. So while you're doing it, you're doing these super small, boring steps. It's overall rewarding because you keep making these little steps progressively and get better and better and better rapidly. Big steps tend to be big problems, and that can be like frustrating and whatever, as opposed to just sort of like, just going to keep on going. All the laundry's getting folded. So that's kind of my talk here. Now, I think there's been a couple questions. So one of them is, how do you develop the big picture, all the steps? Oh, okay. So that's evolved over time. Probably the best way I've seen it described was from Kent Beck's book on TDD. And he basically advocates you write down all the problems that you need to solve, and you just write them down however you intuitively write them down. And then you pick whichever one you're going to start with. It doesn't really matter. And then you just break it down again, and you break it down again. And again, the heuristic I do quite literally use is, when it feels stupid and tedious, that's the right level. I know I can be smarter than that, but I do look for the point where I feel like it's a waste of time level of tedium. And that seems to be about right for me. Microtests, yes, I have bumped into the term microtests, and this might fit that bill pretty well. I just wanted to make the kind of where I might put the distinction a little, not that it matters, is the intent of the cycle was for learning and not necessarily for development, which shifts it a little bit, right? Like, I would, in the same project, I wrote dozens of tests about confirming I knew how numbers worked. Because our bidding would look like $20 a bid, but behind the scenes, it would turn into what's called a microdollar. And that is a very precise number. So I had to be very accurate about how numbers worked, and I couldn't assume my knowledge of precision in like floating points was correct. So I had to actually confirm that was true. And while that looked like a microtest, it was really about me confirming what I knew. So there was a pile of tests about numbers, for example, testing the actual implementation, not because I needed to see it was right, but was I right about it? Just a slight nuance in the intent, but yes, I think structurally looks the same. So with that, I'm going to close the talk. And I'm going to introduce myself last. So I'm Ryan. Hi. I kind of like Amitai said in the bio, I like building really great software teams. It's what I really like to do. And so that's what I do by day as a consultant. And by night, I work with developers trying to help make sure they have the careers they want and the lifestyle they deserve. I'd love for any one of you to reach out to me on LinkedIn and get to know one another. I have a website where I write and ramble and have a newsletter, which I'd love for you to join. But otherwise, thank you so much. And I will answer questions you have about anything you want, even if it has nothing to do with Scala or anything else. We can just hang out and talk. Then I'll leave this open. So if people want to hang out in the social lounge and just chat, whatever, you absolutely can. But otherwise, I want to say thank you, and I hope you found it useful. Amitai, do you want to come back on up here and close this? Oh, questions. The questions feature. All right. Can it make sense to go with a higher approach for learning? Some people charge ahead by hope. Super tiny steps. I mean, thinking through that, I guess I would wonder because it feels like a tortoise and a hare thing, right? So the people who plow ahead to code accumulate a lot of assumptions that it might take a while for the people who are far more, let's just use the word microtest for now, microtesting their knowledge. So what point will they catch up or break even as opposed to always catching up? Will they, I guess I'm worried that the people who are doing the folding laundry are learning and making progress, but the people who are pushing ahead in code are piling up potential disasters at a rate that the laundry people may not quite keep up with. So I don't know, it could be interesting, but that would be one thing I would keep an eye on for sure. Breaking a configuration while it's set up. So I follow the instructions to the letter without understanding them. If something goes wrong, I may not know how to backtrack what to do, right? So when I look at tutorial sites today, what I do now is I frame up what I'm really trying to get to, right? And I write it down as that problem statement. Like, I want to be able to edit stuff in IntelliJ. And then I break that problem further down. And somewhere in there, I will bump into configuration options. But when I'm getting to that micro test about, I want to run SBT through IntelliJ, I make a prediction about what will happen. And when I get a surprise, now I have a reason to read something. Now I have to go learn it. And that might mean I go look at a site, and now I have a lot more context as to when I'm reading these steps, does that step look like it would affect my experiment? And if so, I can try it really quick. And it's the only thing I'm changing, so it's easy for me to undo and back out and see what it does. So that's kind of a cool trick that I've enjoyed, is all those tutorial sites, which they have a lot of implicit information that's not always called out. But when you basically create all that context for the microtest, you have a really good idea of this thing affects that thing level of causation. So you can say that configuration is making a difference, so that's good, and this one doesn't, and that's bad. And that's when tutorials can actually begin to become really helpful, because you can retarget parts of them as opposed to, I would say, being held hostage to all of it working. Big picture, all the steps. I think I mentioned that one already about just write down the problems you need to solve and then try to break them down to the point where it feels like you're folding laundry. I mean, I should have a better analogy, but that's quite literally how I describe it to teams still, is we're going to fold laundry for a while. It'll be okay. And I actually prefer, I mean, one other thing about this is, if you accumulate knowledge this way, right? Just something to think about. If you accumulate knowledge this way, you might have a very, very fine-grained level of detail and information that is really valuable to teams and people around you. However, I would like for you to think about when other people are trying to learn stuff, right? They're going to consume volumes of information, tutorial sites, videos, whatever. They may not actually be able to consume what you know without going through this themselves. Because it's just another point of information in a sea of information that doesn't have a connection yet until they hit the wall. And when they hit the wall, then the information matters. Up until that point, you know, like I'm kind of a firm believer of people can consume tons of information, but until they hit the moment where that information is applied, it may not always connect. So it's sometimes useful to go through these steps with people so that they actually get the experience side of the information as opposed to just data entry into their head, because they may not have an association yet that can be used. And this is something that happened with the team that took over this project. They would call on me for a stack trace, and I'd be like, "That's blah 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 blah," and they would be like, "No, that can't be true." I'm like, "Well, it literally is, but okay. Good luck with Google." You know, the information was there, but they weren't ready for it. Anything else from anyone? I will hang out as long as y'all want. It's better than what else I'm doing. And if I didn't answer someone's question to your satisfaction or I missed one, just let me know. All right. I'm going to end this. Yeah, I think that's a great idea, Barry. So what I'm going to do is end this thing where you're all staring at my head. We'll go back to the social lounge. We can sit at tables and talk. Hope that works. That'll end the recording and all that kind of stuff. Thank you so much for listening, and please do reach out to me. I love geeking out about this stuff. I hope you all have a great rest of the day.